In this video, we're going to take a look at division in scientific notation. So suppose I have two numbers, both written in scientific notation. So in this case, let's do 6.8 times 10 to the 21st power. And I want to divide that by, let's say, 3.4 times 10 to the 6th power. And what we're going to do with this problem is separate it much like what we did with division, or with multiplication, and look at the 6.8 divided by 3.4, and to look at the 10 to the 21st over 10 to the 6th power. So I'm going to treat the 6.8 divided by 3.4 like normal division. 6.8 divided by 3.4 is going to be 2. And then for the second part of this, since I have the common base of 10, this will be like I've got 10 to the 21st. I'm going to take away 6. So that's going to give me 10 to the 15th power. And so that becomes my answer. 6.8 times 10 to the 21st divided by 3.4 times 10 to the 6th is going to give me 2 times 10 to the 15th power. So this is going to be a pretty simple process with scientific notation. What I'm going to do is to divide the first two numbers, okay, by each other. And then I'm going to keep the 10, and then I'm going to subtract the exponents. Okay, so let's look at two other examples of things that could possibly happen while I'm working on this. One thing that could happen is if I'm dividing these, so if I have 9.3 divided by 3.1, okay, let's suppose I have this times 10 to the 12th power, and I have a negative exponent here, like let's say it's times 10 to the negative 4th. I'm still going to do the 9.3 times 3.1, it's going to give me 3, and I'm going to still do the same thing with the 10 to the 12th minus a negative 4. So in this case, it's going to be 10 times 10. The minus and negative becomes two positives, so I'm left with 10 to the 16th power. So just keeping in mind that the normal rules with integers apply as far as with that subtraction. So if it was negative 12 minus 4, I'd get negative 16, okay? So just beware that, make sure you're just doing the top minus the bottom, and then making sure your integers match up there. The other thing to be careful of is sometimes we have the same we did with multiplication, that if I have a certain problem, in this case, I've got 2 times 10 to the 10th power over 8 times 10 to the 16th power. If I take the 2 divided by 8, I get 1/4, or 0.25. And then if I take the 10 to the 10th power and then I subtract 16, I'm going to get times 10 to the negative 6. One thing to be careful of while you're doing this division work, with scientific notation, I've done everything correct up to this point, but the 0.25 is not in scientific notation. I would have to do 2.5 to make it in scientific notation, and since I made a smaller number, 0.25, bigger, I'm going to have to make it times 10 to the negative 7th. Now just to be careful of something, if I was to change this around and make it 2 times 10 to the 16th power over 8 times 10 to the 10th power, I'm still going to do the 0.25 for the 2 over 8, but the 10's become 10 to the 16th minus 10, so in other words times 10 to the 6th power. 16 minus 10 is going to be 6. In moving the decimal place over, making a smaller number bigger, I have to lower this exponent by 1, make it 10 to the 5th. So just how I lowered the -6 to -7, I need to do the same thing. The 6 goes down 1 to give me 5. So that's the only thing to be kind of careful about in making sure those scientific notation matches up. If you're not sure, 0.25 times 10 to the 6, which means I take 0.25 and I move this over 1, 2, 3, 4, 5, 6 spots. Fill in the zeros. Okay, so if I wanted to say, okay, I've got 250,000, and I want to know what that's in scientific notation, I could practice move 1, 2, 3, 4, 5 spots, which would give me my correct answer of 2.5 times 10 to the 5th power. So just know that if you're ever not sure, you can always write it out, see what your answer is.